Imagine this. Over 100 million bullets are fired every day in the world, and most people have never stopped to think about what lies behind something so small, yet so powerful. You've seen a bullet, but do you really know how it's made? Today we're going to delve into one of the most controlled and intriguing industrial processes on the planet. And believe me, what you're about to see is far more complex than it seems. To begin, we need to understand that a bullet is not just a piece of metal. It is an assembly of four components that need to work in absolute harmony. The primer, the gunpowder, the fulminating capsule, and the projectile. If just one of them fails, the entire end result is compromised. That's why ammunition production is treated as precision engineering, where even a grain out of place can put the entire batch at risk. The first stage happens long before the assembly line starts moving. This is where the selection and preparation of materials comes in. Nothing is chosen by chance. The bushing, for example, is almost always made of brass, a mixture of copper and zinc that combines strength, elasticity, and durability. It needs to be strong enough to withstand the internal explosion, but also malleable enough to be molded perfectly. These brass sheets arrive at the factory in large, shiny, and heavy coils. From there, they go to enormous machines that cut small metal discs, tiny pieces that in a few seconds will become the body of the bullet. There is no human touch in this process. Everything is automated, precise, fast, and rigorously monitored. At the same time, in another section of the facility, modern gunpowder is stored, very different from that used centuries ago. It is a chemical mixture specially formulated to generate a large amount of gas in fractions of a second. Enough gas to propel the projectile out of the barrel at speeds that can exceed 800 km/h. For safety, the gunpowder is kept in armored, isolated, and meticulously controlled storage areas. Meanwhile, the primer capsule, the sensitive heart of the entire ammunition, is stored separately. This small metallic disc contains a highly reactive compound that reacts to the slightest impact. Therefore, all its transport and handling are subject to extremely strict rules. And of course, there's still the projectile, the head of the bullet, which begins its life as blocks of molten lead before gaining shape, weight, and coating. At the end of this stage, all the components, metal, chemical, and mechanical, are ready, organized, and catalogued. The machines are calibrated, the sensors are tested, and the workers perform the final checks. Now, the factory can breathe a sigh of relief and begin continuous production. And this is where the real magic begins. With all the materials separated and prepared, the most intense stage of the entire production line begins: the transformation of the raw metal into the perfect casing, the structure that will support the controlled explosion inside the bullet. It all begins with those small brass discs cut in the previous chapter. They travel along conveyor belts to gigantic automatic hydraulic presses, machines capable of applying hundreds of tons of force in milliseconds. With each press stroke, a disc lengthens, thins, and begins to take the shape of a small cylinder, the skeleton of the future bullet. This process is called deep drawing, and its precision is so extreme that any difference of tenths of a millimeter is grounds for rejection. After the initial molding, each piece undergoes further stretching and calibration stages. The base of the cartridge case needs to be thick enough to withstand the impact of the firing pin, while the walls must have uniform thickness to prevent ruptures upon firing. Machines with laser sensors check every detail, while the cartridge case rotates at high speed. Once the mold is perfect, the bushings enter an industrial washing system. They are immersed in chemical baths that remove metal residue, oak, and small particles from the pressing process. Then, they are dried with jets of compressed air. The goal is to leave them as clean as possible. After all, any impurity can affect the gunpowder or cause corrosion. Now comes a critical part: the recording of identification information. Each cartridge case goes through a stamping system that prints data such as caliber, batch, and brand. This step ensures complete traceability of each piece, something fundamental in high-responsibility industries like ammunition manufacturing. With the body ready, it's time to add what makes everything functional: the gunpowder. This step is done in a completely isolated area of the factory. There, high-precision dosing machines measure the exact amount of gunpowder that will go into each cartridge case. Not a grain more, not a grain less. An excess could cause an uncontrolled explosion. An insufficient amount, a weak or misfired bullet. The casings align on a vibrating tray, while an automatic nozzle deposits the explosive charge with millimeter precision. Sensors weigh each unit in real time and reject any that are outside the established standard. Soon after, the powder-filled casing undergoes a slight vibration, which settles the charge to the bottom and eliminates small air pockets. Now it is ready to receive another essential component, the fulminating capsule, installed at the base of the piece. This capsule is placed by robotic systems that apply the precise pressure to fit without deforming the metal or overcompressing the fulminate. Each unit passes through optical sensors that confirm perfect positioning. And so the casing is officially alive. There's gunpowder inside, there's a detonator behind it, and everything is ready for the most symbolic and recognizable step in manufacturing: the union with the projectile, the actual bullet. With the primer fully prepared, powder measured, primer installed, and everything perfectly clean, the time comes to create the element that truly gets the factory going: the projectile. It's what will fly, penetrate, pierce, and hit the target. But to do that, it needs to be born with an almost surgical combination of density, shape, and resistance. It all begins with blocks of pure lead, which are melted in enormous furnaces at extremely high temperatures. When it reaches the ideal point, the liquid metal is poured into cylindrical molds, forming small, rounded cores. These still raw pieces then pass through an extrusion machine that elongates, thins, and gives them their final aerodynamic shape. Each caliber has a specific geometry. There are pointed, rounded, hollow, and even expanding projectiles depending on their use. But the core alone is not enough. To reduce friction inside the barrel and increase durability, these cores are coated with a thin layer of copper. The process is done by chemical bath, where each piece undergoes an electrolytic reaction that creates a uniform metallic coating. In the end, all the projectiles shine like small pieces of luxury engineering. Once ready, they move along automated conveyor belts to the final stage of production, joining with the cartridge case. Here, everything needs to align perfectly. A high-precision machine fits the projectile into the cartridge case mouth, applying calculated pressure to ensure it is secure without gaps or crushing. This joining is known as crimping, and it ensures that the projectile does not come loose with the recoil of the weapon when fired. With the bullet already assembled, one of the most rigorous processes in the entire factory begins: the final inspection. Machines equipped with high-resolution cameras, laser sensors, and ultra-sensitive scales analyze each unit. They check total weight, projectile placement, alignment, powder quantity, casing thickness, and dozens of other factors. Any minimal variation means immediate disposal. Next, samples from each batch are sent to the factory's own testing field. There, specialized technicians fire ammunition under controlled conditions, recording speed, stability, dispersion, and impact. If anything isn't perfect, the entire batch is halted and adjusted. Nothing goes out into the world without maximum approval. After all, a poorly manufactured bullet can literally cost lives. Only after this process do the approved bullets proceed to packaging and distribution. Automated machines organize the ammunition into trays, insert them into reinforced boxes, seal them, and label them with caliber, batch, and production date information. Entire pallets are sent to logistics centers, and from there distributed to armed forces, police, specialized stores, and shooting clubs in various countries. And so, from a simple metal disc to a piece of engineering capable of reaching extreme speeds, a bullet is born. A process that blends technology, chemistry, millimeter precision, and a great deal of responsibility. Now I want to know from you, did you ever imagine that the manufacturing of a candy had so many steps and so much control? Comment below what surprised you the most. And of course, if you liked the video, leave a like, subscribe to the channel, and activate the bell to follow more incredible industrial processes like this one.